Hello Algebra 2 class. For today's classwork, we're going to find the cosine and sine values of given radians. Sorry, I should have written radians here. And we're going to do 4 radian measures to get this practice down in anticipation of your homework that's going to be due the next day. Alright, so let's start with 7 pi over 2. When we translated degrees to radian measures, we are familiar with the following as our most basic radian measures. From here, we do want to make sure that we can interpret 7 pi over 2 correctly. So we're going to make everything into a number over 2. So this is 1 pi, in other words, it's going to be 2 over 2. And there's 2 pi, in other words, that's going to be 4 pi over 2. So if I try to put everything in terms of over 2, I should be able to find out the quadrant in which 7 pi over 2 is. So if I go 1 more pi over 2, or 90 degrees, I should get 5 pi over 2 here, 6 pi over 2 here, and 7 pi over 2. So I know that in my unit circle, if I was to graph this radian, I would go 1 time around, go past 4 pi over 2 all the way to this terminal side here, which then leads me to this point on the unit circle. Points on the quadrant, as noted in the con video, are going to be points on a unit circle where the radius is 1. So that's going to be the coordinates 0, negative 1. Since the x value is going to be the cosine value, cosine of 7 pi over 2 then is 0. Since the y value is my sine value, then similarly sine of 7 pi over 2 is negative 1. That's how we're going to find out trig values of radians. Let's just do 3 more because there are only 2 types of special right triangles, and so you're only going to be required to be familiar with 3 different special angles, which we'll look at on number 2, 3, and 4. Alright, so first let's find out where negative 13 pi over 4 is. We're going to try to write everything in terms of divide by 4. So this is typically pi over 2, but instead I'm going to write 2 pi over 4. Likewise, I'm going to, instead of writing pi, write 4 pi over 4. Instead of 3 pi over 2, 6 pi over 4. And instead of 2 pi, 8 pi over 4. Now, you might have already caught the mistake that I made, which is not to consider that it's going to be a negative. So for a negative radian, just remember it's going to go backwards this way. So instead, this will be 6 pi over 4, and this will be 2 pi over 4, and they will all be negative. So let's continue until we get to 13 pi over 4. We've made 1 full circle around. We're going to continue. So this now becomes negative 10 pi over 4. This is negative 12 pi over 4. And this is negative 14 pi over 4. So we know that it's going to go all the way to this quadrant for negative 13 pi over 4, which is between negative 14 pi and negative 12 pi over 4. This also allows us to correctly draw the right triangle. The reason why we want to draw the right triangle is because this coordinate will help us determine the cosine and the sine values. So I've reproduced this triangle here, where our reference angle is going to be pi over 4. Now pi over 4 is going to be the same thing as 45 degrees. And that allows us to reference the special triangle 45, 45, 90 triangle with these specific values. For the triangle at hand, we know that the radius of our unit circle is always going to be 1. So since this 1 is going to match this hypotenuse here, we know that 1 equals side times square root of 2. We're going to divide by square root of 2 on both sides to get one side, And so side equals, once we rationalize the denominator, square root of 2 over 2. So that means this side is now going to be represented by square root of 2 over 2, along with this side as well. Now that means this value is square root of 2 over 2 as my y value, and this value is my x value, but since it's in the negative x-axis, this will be negative. If we were to just take what we want, sorry for, just bear with me for a second. All right, so that means my coordinate for this point here is going to be negative square root 2 over 2, represented by my x value, and positive square root 2 over 2 as my y value here. So that means my x, or cosine of negative 13 pi over 4, is going to be negative square root 2 over 2. My y, or sine of negative 13 pi over 4, is positive square root 2 over 2. So we went over the 45, 45, 90 triangle. Let's go over the 30, 60, 90 triangle. So the third radian we're going to graph out is 13 pi over 6. So similarly, let's rewrite pi over 2 pi and 3 pi over 2 and 2 pi in terms of a denominator of 6. So this becomes 3 pi over 6. This becomes 6 pi over 6. This becomes 9 pi over 6. And 12 pi over 6. So we know that our radian measure goes a full circle and then some. In fact, it's going to go just pi over 6 more to create this right triangle, and we're now going to figure out this coordinate. So again, since the radius is 1, we can reference this triangle with the correct special triangle. Pi over 6 is going to be 30 degrees. So we can reference the 30, 60, 90 triangle. 30 degrees will be across the shortest side. The longer leg will be the shortest side times square root of 3, and the hypotenuse will be 2 times the side. So we know that the hypotenuse is going to be 1. So 1 equals 2 times the side. So that means the side is going to be 1 over 2, or the shortest side. So that means this value here is 1 over 2. And this value here is just 1 over 2 times square root of 3. So that's square root of 3 over 2. That means the coordinates of this dot right here is going to be the x value, square root of 3 over 2, and the y value, 1 over 2. It is in the first quadrant, so they're both positive, and that will mean that the cosine of 13 pi over 6 is positive square root of 3 over 2, and the sine of 13 pi over 6 is 1 over 2. Lastly, we're going to use the same special triangle, but this time using 60 degrees as our reference angle. So here we have an odd denominator. It's divided by 3. So in order to make sure that we can correctly translate this with our given radians, which have a denominator of 2, I'm simply going to use the lowest common denominator and use negative 26 pi over 6. So since you're already familiar with the process, I'm going to just use some shortcuts here. We're going to go backwards 1 full circle, because negative 2 pi is the same thing as negative 12 pi over 6. We definitely need to go way further. So I'm going to go 1 more full circle to get to negative 24 pi over 6. Then a pi over 2 more is the same thing as 3 pi over 6. So that's going to give us negative 27 pi over 6. So we know it's going to be here between. and this would give us negative 25 pi over 6. So I now have it. I have where it should end. It should end exactly here. So I can now draw the following right triangle. And again, the purpose of this is to find out the coordinate on the unit circle. Okay, so what is our reference angle? Our reference angle then would be pi over 3, or it would be, this would be based on a picture pi over 6. So that means this would be 2 pi over 6, or in other words, pi over 3. Now pi over 3 is going to be 60 degrees. So we can reference this triangle here. Again, we know the hypotenuse is going to be 1. For that special triangle, it's going to be 2 times the side. So similarly, the side is going to be 1 over 2, and the longer leg will be square root of 3 over 2. So going back to this picture, we have this length as square root of 3 over 2, this length as 1 over 2. This is a positive x, as you can see here, but this is on the negative y. So our coordinates are actually going to result as follows. So the cosine of this radian measure is going to be positive 1 over 2. The sine of this radian measure will be negative square root 3 over 2. All right, I've said a mouthful. If you have any questions, please call the school or email me personally. All right, good luck.